Well, hello future engineers, how are you all? Welcome to our platform Diksha Karnataka, where learning is fun. Today we are cracking one of the very important session which is going to be on JEE Mains PYQ of the chapter inverse trigonometric function. I hope this is very much clear. JEE Mains PYQs from last 4-5 years I've taken. Total of 18 questions approximately. We're going to solve it in the session today itself in detail. Don't worry. After solving these questions, you'll not have any doubts from these many questions that I'm going to explain it to you. And of course, building on that, you can solve many more problems and ask your doubts over here to me. This is clear. Okay, so we have already covered our concept sessions of ITF, right? We have done that in two parts, part 1 and part 2. If you are watching this video for the first time, you can go ahead and check that out. Okay, then we moved on in the part 3 of the session. You can see the planner over here. We moved on to the part 3 of the session, which was about KCET PYQs. Part 1 2 was on the concept. You can see the topics written over here: inverse of function, ITF, domain and range. Part 2 was properties of ITF, and part 3 was KCET PYQs, and part 4, which is this particular session, on the JEE Mains PYQs. Very good. So as you know, the Sankalp batch structure is very similar. You have concept sessions moving on, then you get KCET PYQs and followed by JEE Mains PYQs. There's no doubts whatsoever in this particular thing, right? How the planner is working out for all of you. Now, why are we here? We are here to make sure that we're gonna work hard this entire year and be one of the rankers and toppers in the next year's batch, right? These are the results just from YouTube that we got in the last year in our first year preparation. This was KCET 2025 batch, our first batch of students who have got a very decent, very good rank in KCET, which was achieved by Prajwal, Kiran, Diksha, Samiksha, Sachin. There were many more. Okay, we can't take all the names. We can't put all the names in the one slide also, but our goal is very simple. We'll work very hard this entire year and we'll achieve our dream college very safely. We won't have a last minute hassle or troubles in our colleges. We make sure that we're gonna get a very good rank, very good marks in our examination and get the desired college. Okay, so that is our goal that is set for us. Now today's session is based upon, as I said, JEE Mains PYQs last 4 years, total of 18 questions. I've taken very good questions. Okay, so yes, it might require a little bit of effort from your side. What you can do is, I'll try to go slow, I'll try to explain you all the concepts, but meanwhile, please, if you are not able to understand any particular question, pause the video. Okay, do try from your side whatever you know and then come back and see the rest of the question solution, because when you do from your side, you're able to relate better in the questions. Won't you all agree? And please watch this session a couple of more times so that you can get the idea of the questions if you are having trouble doing that. Okay, so yeah, most of the questions are very easy, but yeah, few questions are challenging, but it is going to be like that in any of the examinations. So let's solve first question. Okay, first question is simple one. Let's solve it. 2nd April, shift number 2, 2025 paper. Again, as a JEE main question. Y equal to cos pi by 3 plus cos inverse of x by 2. Then we are looking for the value. It's a numerical type question. Okay, x minus y the whole square plus 3y square is equal to what? Okay, let's find the answer. So first thing first, what are you going to do right now? 1 second. What are we going to do right now, sir? So we'll look for what they have given to us. What they have given to us. So you can see there is something in terms of cos. Yeah, cos of a plus b is forming here, sir. Cos inverse of x by 2 is also an angle, right? Cos inverse of x by 2 is also an angle. It means that cos of a plus b formula will be valid over here. Yes. What's the formula for cos of a plus b? Cos a cos b minus sin a sin b. Let's write that. So I have over here y equals to cos of a, that is cos pi by 3. Then you have cos b. When you do cos b, you'll have cos of cos inverse. You'll have cos of cos inverse. What is that going to be? Remember, this is going to be simply x by 2. So cos pi by 3 into x by 2. Okay, next step, what is the next step? There comes a minus sign. Next you have sin pi by 3 and you'll have sine of cos inverse x by 2. Now please pay attention. If this is the angle over here, if this is the angle over here, some angle alpha, let's say, okay, this is the current condition like this. If you have sine, if you have already given cos alpha, let's say, if you have cos alpha as x by 2, then simply sine alpha will become 1 minus x square by x by 2 the whole square, sorry. Yeah, x by 2 the whole square, which is basically sine square alpha. Have I gone fast? Please tell me. 1 second. So I can write like this, no? Cos square alpha in the root. Yes or no? If I already have the value of cos alpha given to us, I can find sin alpha from there using this formula. What is cos alpha going to be? X by 2. If this is the whole thing is alpha, it means cos alpha is x by 2. From here I can get sin alpha simply as, check this out, 1 minus x square by 4 in the root. How much is that? 4 minus x square by 4 in the root. How much is that? 4 minus x square divided by 2. Okay, I'll put that value over here. 4 minus x square divided by 2. Clear? So let's proceed with a couple of more steps. If you want to have a look of this, please pause the video, write these steps because I'm going to delete it later. This is just for the rough work, okay? So we can, if you know these steps, you don't have to do all of this. Directly you can write this step. First step should be directly written from your side. After practice, you will get to know all the steps. Very simple. They are very, very simple ones. But if somebody is not knowing this, that's why I've done it over here, just for the first time. Okay. Y equals to cos pi by 3 is what? 1 by 2. This is x by 2 minus sin pi by 3 is root 3 by 2. And we have in the root 4 minus x square by 2. I think LCM is clearly there. 4. Okay. I get x over here. I get root 3. 4 minus x square. Cross multiply. I get 4y equals to x minus root 3 root 4 minus x square. Okay. Bring the root term on this side and this 4y on that side. So I have here root 3 root 4 minus x square and x minus 4y. What I've done now, I've taken the root part on this side so that if I square on both sides, I'll get rid of the root. Getting my point? I've taken this root terms on one of the sides and other terms on the other side, so that when I square this term on both sides, I get rid of the root. Okay. I'm going to erase this all steps, rough work that I've done. Okay. I hope you already copied that or you have understood this part. Great. Just give me 1 second. Okay. So here we go. Yes, this is just for your reference. You can use it. What I get from here, if I square on both sides, from here, I'm getting what? Squaring both sides. This is my equation number 1, let's call it. Equation 1. I'm going to end up with, I'll have here 3 times of 4 minus x square, right? Because both the roots will be cancelled when you square on both sides. And this side you'll have x square plus 16y square. I'm using the formula of a minus b the whole square, right? A minus b the whole square. So x square plus 16y square minus 8xy. How come, sir? 2 into x into 4y. That becomes 8xy. Alright. So with that known, I can expand it over here and write the constant here. 3 into 4 is 12. And I get here minus 3x square. Move on that side, I get x square plus 3x square. I'll explain one more time. Minus 3x square moves on this side, becomes plus 3x square. Okay, great. I have here 16y square minus 8xy. Okay. So what I'm getting here, 4x square, right? I'm getting here is 4x square plus 16y square minus 8xy. I know this is one more step, we didn't require that. Take 4 common, I get x square. I'll take this term over here, I get right here 2xy with a minus sign and comes 4y square. Okay, this is 12. Cancel this. 4 3s are 12, right? Correct? So far so good. Right here 3 equals to x square I have minus 2xy I have. I need one y square. Why I need y square? Think about it. X square minus 2xy plus y square will become x minus y the whole square. So right here plus y square. I already have 4y square. Already have 4y square. If I take one y square from there, how much I have left? 3y square is left. Okay. Continue the steps over here. I'll have 3 as it is, x minus y the whole square and plus 3y square. Check this out. X minus y the whole square plus 3y square, and this is equal to what? We are getting a number over here, 3. Answer is 3. Answer is 3. So your answer over here, I can highlight it. Your answer for this particular question is 3. Have a look. Okay. I hope this is all clear to you. Simple question. Moving on to question number 2 now. Okay. Don't worry, no need to rush. Simply, we'll take some time, but we'll solve all the questions. That's very, very important, right? So question number 2, yes, cot inverse of 1 plus tan square 2 minus 1. I can see there's a formula of 1 plus tan square. What is that? Sec square. 1 plus tan square theta is sec square theta. Okay. So, excellent. If I do that, again, these are the values given in 2, 1 by 2 like that. It means it's given in radians. Okay, 2 radians, 1 by 2 radians. All right. So if I simplify this step, I'll have here cot inverse 1 plus tan square will become sec square 2 in the root, minus 1 comes here. We have tan 2. We have tan 2. Okay. Same way, I can write this step also. So I have again minus cot inverse, and this time again I'll have a root of sec square 1 by 2, okay, plus 1 divided by tan 1 by 2, right? Plus 1 divided by tan 1 by 2. Okay. So let's carry on. Let us carry on what we have. Okay, now understand this very carefully. Sec 2, the 2 radian angle is in which quadrant? Pi is 3.14. Pi by 2 will be something around 1.6 something. Okay, so 2 radian is going to be in second quadrant. Have a look. So this is pi by 2, right? Pi by 2 is nothing but 1.58 something like that. Correct, na? 3.14 is the value of pi. So pi by 2 will become half of 3, almost 1.6, 1.58. So this is approximate value, not accurate. Please check that value out, but doesn't matter. This gives means sec 2 will be in which quadrant? In the second quadrant. Second quadrant, sec is negative or positive? Negative. Second quadrant, sine and cosec is positive. Quadrant rule. So from there I can get directly from over here. Cot inverse, the root will come out as, since we're taking root, right? The root will have both answer plus and minus. But this is in second quadrant. The angle sec 2 is in second quadrant, which will give me here minus sec 2 minus 1 divided by tan 2. Okay. How about this step? So this is going to be simple enough. This is going to be sec 1 by 2. So first quadrant, right, will remain positive only. So we have here sec 1 by 2 plus 1 divided by tan 1 by 2. Okay, this is the only step which was important. Rest all is very, very simple. We'll make everything in terms of sine and cos and simplify. Okay, so we get here cot inverse. This will become, I can take my sine common. So I'll have here 1 by cos theta, sorry, 2, right, not theta. 1 by cos 2, 1 by cos 2 plus 1 divided by tan will become sine by cos 2, sine 2 by cos 2. Okay, so this bracket is closed. Same way I can get on this side also. We have cot inverse, and this bracket will become same thing, 1 by cos 2 plus 1 by sine 2 by cos 2. I hope this is all clear to you. Yeah, 1 by cos 2 is for sec and tan is simply, okay, not 2, right? It is 1 by 2, no? So I can write it as 0.5 everywhere. I write it as 0.5 everywhere. That is okay. Cos of 0.5, sine of 0.5 and cos of 0.5. Because it is 1 by 2, I'm just writing it. We don't have space to write 1 by 2 everywhere. So I wrote 1.5. This is okay. All right. So now check this out. I have 1 plus cos. If I take LCM over here, what I get? I get cot inverse of 1 plus, there's a minus sign of cos, 1 plus cos 2 divided by sine 2. Why not? What happened to cos 2, cos 2? They get cancelled, okay? The denominators on the both sides will get cancelled. Same goes over there. I get minus cot inverse. I get 1 plus cos 0.5 divided by sine 0.5. right? 1 plus cos, because if we take LCM, it will become cos 0.5 over here. 1 plus cos 0.5 by cos 0.5, which will cancel this cos. This and this will be cancelled over here. Got it? Okay. So 1 plus cos, there is a formula for 1 plus cos. If you remember, the formula is simply 2 cos square 1, half of the angle, and over here for sin 2 also we have formula 2 sin 1 and cos 1. 2 sin 1 and cos 1. Okay, and this will turn out to be in same fashion cot inverse of 2 cos square 0.5 half, right? Half of 0.5 is how much? 0.25. 2 cos square 0.25. Half of half is 0.25, okay? And over here again we get 2 sin 0.25 and cos 0.25. Okay, so I have here cos is cancelled, one of the cos's. Here also one of the cos's is cancelled. We have 2 and 2 is cancelled. Okay, the last step. Check this out. Cot inverse of cos by sin becomes cot 1, right? Cot 1. Sorry, just little bit calculative question, not difficult at all. I hope you can see that. The question is calculative, okay? If I wanted, I could have given you after a few steps to solve from your side. But I don't want to do that. I want to solve all the steps for you. That works. Okay, just bear with me for some time. The question is almost solved. So cot inverse of minus cot 1, because we have cos 1 by sin 1. Everything else is cancelled in the first term. Second term also you see, we have cos 0.25 and sin 0.25. That's all. So I get here minus cot inverse of cot 0.25. Formula is final. This pi minus this value will become 1 minus again will become 0.25. How much is that? 1 by 4. Cot inverse of cot will be cancelled. 0.25 will be what? 1 by 4. I can write that 1 by 4. So my answer is now final. We have achieved 5 pi is as it is, and minus 1 by 4 will become minus 5 by 4. Option A is correct. Have a look. Yeah, I understand it is little bit calculative, it is little bit confusing if you might feel that way. Okay, this is written as cos 0.25. If it's not clear, I'll just erase this and write it better. This is cos 0.25. okay, I'm not able to erase it. Alright, I'll just check why I'm not able to erase it. Yeah, so this is cos 0.25, which I've cancelled now. This is cos 0.25, okay, which I cancelled with the cos square 0.25 in the numerator. 2 and 2 is cancelled. Have a look. If you are confused about this question, do one thing, pause the video, try right now and then go ahead to the next question. It's important to solve this kind of questions. Okay, next we can move to question number 3. Okay, question number 3 now. Using the principal values of the inverse trigonometric functions, the sum of the maximum and the minimum values of a given function in terms of ITF is going to be how much? They're asking us maximum and minimum value sum. So we have to first identify the function over here in one of the forms. We'll simplify it, and then what are you going to do? Maximize and minimize it. Okay, so let's have a look what we're going to get. So if I take this angle as, let's say, alpha, sec inverse x is alpha. What happens to cosec inverse of x? This will become pi by 2 minus alpha. How come, sir? Sec inverse x plus cosec inverse of x is pi by 2. So if sec inverse of x is an angle alpha, what happened to the other angle? Pi by 2 minus alpha. Works? Okay. So I can write this as a function y equals to 16 times of alpha square, no? Alpha square plus pi by 2 minus alpha the whole square. Okay, all right. And what is the domain? What is the alpha range? You can see from here the alpha will actually sec inverse, right? So this alpha will belong to 0 to pi except for pi by 2, except for pi by 2. Okay, that's for alpha, the angle alpha. Okay, great, got it. So we have the boundaries now. The boundary is 0 pi. Okay, the domain is known. We have to identify the maximum minima in the domain only, right? The domain is known as 0 to pi minus pi by 2. Great. So we have alpha square plus, okay, let's expand this. So we get y equals to 16 alpha square, the variable is alpha over here, and I get pi square by 4 plus alpha square minus pi alpha. Okay, simplifying things, I'll get 16, I'll have 4 alpha square. Okay, no, 8 alpha square, because we have two places alpha square, right? So you'll have this as 8 alpha square. This and this will become 2, right? So 8 alpha square minus pi alpha plus pi square by 4. How do you find any maximum minimum value? You have to differentiate to get the critical point. So let's do that. Find y dash. You'll have y dash as it is, constant 16 as it is, it becomes 16 alpha, okay, here minus pi. All right, okay, 1 second, I think I have made some mistake. Yeah, this will become 4, right? In that case, if I take pi, if I take 4 over here, I'm taking, okay, there's something wrong. Yes, 1 second here. So I'm taking the LCM as 4, right? I'm taking 4 multiplication. The function itself is wrong. I have to correct that. Just give me 1 second. I've made a calculation mistake. So this will become 4 alpha square. So pi square is as it is. We get now that as minus 4 pi alpha. Minus 4 pi alpha. Correct, na? Because I'm multiplying 4 to everything. It will become like that only, right? And you have to divide this by 4 also. You're multiplying this by 4, right? So to divide that by 4. Okay, so this will be simply 4. So my function is going to be y equals to 4 times of 8 alpha square minus 4 pi alpha plus pi square. That's my function. Now I'm going to find a derivative. No problem. Let's find the derivative now. So I get y dash equals to 4 as it is. This will become 16 alpha minus 4 pi, and this will be 0. Pi square is a constant, so 0. Okay, and this if you put it equal to 0 to find the critical point. That's how you do it. How do you find critical point? Find the derivative and that put equal to 0. I'll repeat myself. How do you find the critical point? What is the critical point? Where you have the slope maxima or minima. This kind of slope will be there. Okay, where you have like slope parallel to x-axis. Only when you get the critical points. And critical points, how do you find that? By putting the derivative equal to 0. Okay, we'll learn more of that. If you're somebody who's not about to understand this part, don't worry. When I teach you AOD, I'll teach you critical points and everything. Okay, so from here, just for now, let's solve it. 16 alpha minus 4 pi is 0. I get pi value, sorry, I get alpha value as pi by 4, I think. Yeah, alpha value is pi by 4. We are getting only one critical point over here. Only one critical point. So let's find the function value y at pi by 4. Okay, you can do that. You can find second derivative and check the nature, but don't worry, it'll come out as minima only. Okay, if you want, you can find the second derivative also, not a problem. So check, it'll come out as positive. Second derivative positive means, so somebody who knows that, who's a repeater, second derivative positive means point of minima, right? So you're gonna get this as 16 into 4, 64. That's the second derivative. Okay, so what we have over here is simply minima. Point of minima is pi by 4. Let's put this pi by 4 in this part. What I'm getting, I have here 4. Okay, and I get 8 into pi by 4, right? So 8 into pi square by 16, and I get here, this is pi alpha, so pi square, it becomes correct now, because if you put pi by 4, 4 and 4 will be cancelled, you get pi square, that is again plus pi square. So cancel. My answer will become, please check, we have 8 for the 32, simply 2 pi square. This is my minima. This is my minima. Okay, 8 for the 32 divided by 16 will become 2 pi square. Now we have to look for maxima. If you want to find, we have boundaries known now. What is the boundary in the domain? 0 and pi. 0 and pi. If you put for 0, you'll have this and this 0. You're gonna get only pi square left. Putting alpha as 0, only pi square will be left. 4 pi square I'm getting. That is not minima, is it? No. Okay, it's minima is 2 pi square. Out of the, if you put alpha as 0, you're getting the y value as 4 pi square, which is not the least. Okay, that's why we can't take 0. Now let's look for the other boundary, which is pi, for the maxima. Okay, so I'm going to find the value of the function when alpha is pi. Let's find it out. So I get 4 times is here, I get 8 times of pi square, so it is simply 8 pi square. And over here I have 5 into 4, so 20 minus 20 pi. No, pi, right? Minus 4 pi square, no? Minus 4 pi square. And last one will become again plus pi square. So I have over here what? 8 plus 1 is 9, minus 4 is 5. So I get 4 into 5 pi square. How much is that? 20 pi square. So this is my y value, simply maxima. What are they asking? They are asking us y max plus y min. Okay, 20 pi plus 2. How much is that? 22 pi square. 22 pi square, option A is correct. Have a look. Don't worry, I'll repeat again what I've done. So what I've done over here is simply wrote a function y in terms of the angle alpha that I have assumed. Okay. Now from that principle I got this as alpha, this I got as pi minus alpha the whole square. Simplifying that, I got a function in terms of alpha for the variable y. Okay. I wanted to find maxima and minima sum. How do you find maxima and minima? Using application of derivative. You have to differentiate. Find the critical point. Okay. We differentiated it. Got the critical point as pi by 4. How do you get that? Putting it equal to 0. Okay. Putting derivative equal to 0, we get the critical point. Only one critical point is there. So this is only point of, so only one critical point, and we have other two boundaries also, 0 and pi by 2. 0 and pi by 2. Okay, so we found the value at 0, it was coming as 4 pi square, which is not minima, and then we found the value at pi, then we got the value as 20 pi square. If you take the sum of 20 and 2, answer is coming as 22, which is option number A. Option number A. So question number 3, answer is correct. Okay, option number A. Can I move on to question number 4 now? I hope there is no doubt. Question number 4. Question number 4 for all of us. Let's solve it. So cos inverse of 12 by 13, cos x 5 by 13, sin x. 1 second. Yeah. So okay, let's solve this. Again the same formula we can make here, cos into cos, because to get the cos inverse negated or cancelled out, I need a cos function over there. So it can be formula of cos A cos B sin A sin B. Can you get that part? Yeah, cos A cos B sin A sin B. I hope you're getting this part. Okay, so so I can take this as cos theta is 12 by 13. Then of course, check this out. This is 12, this is 13. This is a Pythagorean triplet, 5, 12 and 13. Okay, so sin theta will basically become 5 by 13. Yeah, so I have the answer as cos inverse cos theta cos x plus sin theta sin x. Sin theta sin x, which is giving me cos inverse of cos of x, excuse me, minus theta, x minus theta. That's the formula of cos x minus theta, cos x cos theta and sin theta sin x with a plus sign. Okay, great. Operated cos inverse of cos, answer will be simply x minus theta. Now they are asking in terms of tan, please check. So if this is my angle theta, tan will be 5 by 12. Okay, so my tan theta will be 5 by 12. It means theta will be tan inverse of 5 by 12. So answers here x minus tan inverse of 5 by 12. So not all questions are difficult, some are easy also. Okay, so even the questions that that was little lengthy, not difficult actually. Third one was very lengthy, second one was lengthy. Yeah, it requires some calculation, but you can do it faster if you are having the practice of the problems. Okay, have a look once, then I start with the question number 5. Works? Question number 4 is done, I think, right? Very simple, very clear. Had fun, sir. Thank you for giving one easy question. Yeah, it is an easy question, of course. Question number 5 will solve now. Okay, now another looks difficult but is very simple. Just one concept is there. This one. Look at the angles. Which is the greater angle over here? Then only it will be easier for you to understand. First condition is alpha minus beta, plus or minus. Alpha minus beta is plus or minus. It is plus because alpha is more than beta. No problem over here. Beta minus gamma, plus or minus. Again plus because beta is more than gamma. No problem over here. But last one you check. Gamma minus alpha. Gamma is smaller than alpha. Check here. Gamma is smaller than alpha. It means Gamma minus alpha will be actually less than 0, will be negative. Okay, then you have to make some changes. First of all, we have everything in terms of cot inverse. We'll make that into terms of tan inverse. It'll be easier, you see. Okay, so what we're going to do, first of all, take LCM. So I'll show you for only this part. Okay, I'll take the others as it is. Just I'll show you for the first part. Check this out. So we have cot inverse. Acha, one more thing. If you have a question like this, you don't have to do for entire term. You can do for the one of the terms, get an idea of the concept from there, which formula you're using, and then directly you can use that similarly for other terms. Okay? Because you can see that there are similar terms, right? Then why to do it for all the terms? Okay? We could have done the same thing over here also. Where? Here also. We don't have to do both the steps. But this is the second question I wanted to do and show you everything. For this question also, I don't have to do the second part. If I do this part only and get the answer, I can say similarly for this part and get the answer. See, it's coming as minus 1 by 4, this is coming as pi minus 1. Aren't these two steps very similar? Yeah? So I could have done for only one part and showed you. But I wanted to show you entire process for at least one question. That's why I've given you the detailed steps over here. But for the current question, question number 5, I'll not do that. I'll do only for the one term, others you can relate to. So let's multiply. We have beta alpha minus beta square plus 1 plus beta square. That's how we take LCM? Yeah? Okay, cancel. So if I have cot inverse, I can write tan inverse also, right, from here. It'll become alpha minus beta upon 1 plus alpha beta. Check carefully. Check carefully. Beta plus beta alpha and plus 1 is left, right? I've written in the cot inverse to tan inverse part. Nothing else I've done. Okay? This is alpha minus beta that goes up, and this whole thing just reverses itself in the reciprocal form. There's a formula for this or not? There is a formula. What is the formula? Tan inverse of alpha minus tan inverse of beta. Right? This is equation number 1. Okay? Equation 1. Tan inverse alpha minus tan inverse beta we are getting from the first part. Similarly, I can do for second part also. Check carefully for this part. It will become simply beta minus gamma. So tan inverse of, I'll get for this part as beta minus gamma upon 1 plus beta gamma. Do one thing. Solve it. Same approach you apply, you're going to get this result, beta minus gamma. So over here what you'll have, tan inverse of beta minus tan inverse of gamma. This is my, let's call it as equation number 2. Okay? Part 2 basically, not equation, part 2. Part 1, part 2. Now part 3 you look at. Part 3 is the very important one. So for the part 3 now, cot inverse, you'll have over here alpha gamma, okay, and you have plus 1 divided by gamma minus alpha. Okay, but it is negative actually. It is negative actually. So then what happens is when you convert to tan inverse, no, there's a process for this. It becomes pi minus tan inverse of alpha minus gamma. Sorry. Yes, so for the third part now, these are the parts, right? Part 1 and part 2. For the third part, so I'm going to do the same step. Check this out. Okay. So I'll have over here cot inverse. Gamma alpha will come, so I can write here alpha gamma plus 1 divided by gamma minus alpha. But we know that this is negative, right? This is negative. Whenever that happens, then when you're doing converting cot inverse to tan inverse, you can make the change. Simply write this as tan inverse of alpha minus gamma, okay, 1 plus alpha gamma, but comes here pi minus. Okay, the conversion is when you're converting from cot inverse to tan inverse, no, there comes a pi minus if the this value is negative. Gamma minus alpha is negative. Okay, check this out. So my final approach for this answer for this part will be pi minus tan inverse of alpha, okay, plus tan inverse of gamma. This is part 3. Now add it. 1 plus 2 plus 3. 1 plus 2 plus 3. See the fun part. Tan inverse alpha positive here, here negative, cancels. Tan inverse beta negative here, here positive, cancelled. Tan inverse gamma positive here, here negative, cancelled. I have only pi left. Answer is equals to pi. Option D is correct. See, another smart and simple question. Smart and simple question. Got it? Yes. Only thing required was knowing the angle, the difference of the angle which is positive, which is negative, and just simplify one of the terms. You can write similarly for the other similar terms. Okay, they are all similar to each other, right? Cot inverse, cot inverse, cot inverse of the same format. Okay, why we wrote in the tan inverse formula? Because we have this formula, no? Tan inverse of alpha minus beta upon 1 plus alpha beta is nothing but tan inverse of alpha minus tan inverse of beta. Got it? Have a look. We'll move on to question number 6 now. Okay, now next question number 6 we have cos of sin inverse 3 by 5, sin inverse 5 by 13. So whenever you see this many plus terms, no, basically understand this. To solve this question, you need finally over here cos inverse, or you need some angle over here. Correct, na? You need some angle over here which can be operated with cos. Otherwise, you can't solve this question. So we have to simplify this in what is there inside the bracket. And the best way to do it right now with the help of tan inverse formula. Remember, tan inverse is easy to solve from there. Let's do it. Convert everything in terms of tan inverse. So we have 3 simple right angle triangles over here. We have here 3 by 5. This becomes 4. Okay, let's call this to be some angle. I can call it to be theta 1, let's say. Then another one we have this as theta 2, let's call it. This is sir 5, this is 13, we know this is going to be 12. And the last one, theta 3, we have here 33, this is 65, this will be, okay, 25, okay, I think 56, check this out, 56 I think, okay. So this is the values that you have. So if I'm asking you to find tan of theta 1, what is the value? Tan theta 1 will be what, dear? It will be 3 by 4, okay. So we get theta 1 value from here as, check this out, theta 1, this is theta 1, right? Theta 2 and theta 3. So right here, cos theta 1 will become what? Tan inverse of 3 by 4. Tan inverse of 3 by 4 plus tan inverse of 5 by 12 plus tan inverse of, how much is it? 33 by 56. 33 by 56. Got it? Let's solve this question now. Okay. So, couple of steps, few more. Keeping cos outside, let's solve this two first. Tan inverse A plus tan inverse B, we have the same formula. Tan inverse of sum of these two, 3 by 4 plus 5 by 12, divided by the product of these two, minus 15 by 48, right? Okay. Oh, I can do better actually, 1 second. I can do better. Yeah. 1 second, sir. No need to do it like this, right? Right here, 3 by 4 into 5 by 12. Got it? So we can cancel this now, that's why. And write this tan inverse of this part as it is. 33 and 56, I think, yeah. Close. So what I'm getting over here is going to be 3 4s is 12. 3 4s is 12. Okay. So I have now cos. LCM will become what? 4 and 12. LCM is 12 only. Okay. 4 3s means 3 3s is 9. 12 and as it is becomes here 5 divided by, I have 16 is, so 16 minus 5 by 16, right? 16 minus 4 into 4 is 16, I take here 1, 16 minus, only 5 left, so 16 minus 5 by 16. And this is as it is, tan inverse of 33 by 56. Let's continue. So 9 plus 5 is 14, I can cancel this right now. 4 3s are 12 and 4 4s are 16. Okay, simplify this now. Simplifying this, I get cos, I have tan inverse, correct? Cos tan inverse I have, 9 plus 5 is 14. So right here, 14 by 3 divided by 11, right? Yeah, 11 by 4. And we have, of course, tan inverse of 33 by 56. Alright. Okay. So I get cos of, simplify this, tan inverse, how much is this? I can get 14 into this 4 will be multiplied to this 14, I get 56 over here. and 3 into 11, I get 33. Okay, I got the answer. This will be 0, I think. Answer is 0. We'll see. 1 second. Just give me one more second. Convert tan inverse to cot inverse. Convert the first tan inverse to cot inverse. Have a look. Cos is here. The cot inverse will give me 33 by 56. Same angle over here. 33 by 56. Check this out. Cot inverse plus tan inverse, the value is simply pi by 2. Outside we have cos. Answer is 0. Calculative but simple question. Calculative but simple question. Yes or no? All of you agree? It made it look difficult because of the calculation, but not difficult at all. Right? So simple. First we had to convert everything in terms of tan. As I said, whenever you see these terms in summation and you have to simplify it, better to use tan inverse, because of this formula, tan inverse of a plus b or tan inverse of a minus b. Both formula works. We use that 2 at a time. We got a result. Then we have to simplify one more time to get tan inverse of this as 33 by 56 in terms of cot. Get the final answer as pi by 2. So cos pi by 2 is 0. Question number 7 now. Okay, they have given greatest integer function. Okay, and that is also in terms of second verse. They are asking us domain of second verse. Okay, so we know that very well. Second verse, if it was like this, let's say y, we know y has to be more than 1 or y has to be less than minus 1. That's how it works. That's the domain of second verse. Okay, so apply this condition both the sides. We have twice of this plus 1 greater than 1. Move this 1 on this side. I have simply this as greater than 0, because 1 minus 1 will become 0. From here I can see simply it will become greater than 0. Correct, no? Divide 2 on that side, it becomes 0 by 2, which is 0. Now GIF of x is more than 0. It means x has to be what? More than 0, right? Right? 0 at 0, GIF of x is 0. Okay? At 0, GIF of x is 0. 0.1 you take, again 0. 1 you take, is become 1, and so on. Okay? So if GIF of x is more than 0 or equal to 0, I have to get the x value also as more than or equal to 0. Second part. Twice of x plus 1 is less than minus 1. On this side I get twice of GIF of x less than minus 2. Move it over here, I get twice of, x is simply less than 2. I have moved on this side, I get minus 1. So from here you can see, I can write this simply as x less than 0, right? Think about it. Less than 0 I can write minus 0.5. What is the answer in GIF? Minus 1. Right? If I put here minus 0.5, what is the answer going to be? Minus 1. So everything less than 0 will be your answer for this side. Combine them together for the final answer. This is your number line. Plus infinity, minus infinity, 0. First part says include 0 and this side. First part said include 0 and the greater side. The second part says exclude 0 and on this side. If you combine together, what do you get? This to this. What is the answer going to be? Negative infinity to positive infinity. Option A is correct, sir. Option A is correct, sir. Simple question. 28th Jan 2025 paper, shift number 2. 7th one is done. Simple enough. Question number 8. So this is what I like. Keep giving us simple question in between. Okay, so that our mood is nice and chilled, enjoying the questions also. Okay, I try my best to incorporate difficult and easy sums together, but it's the chapter's requirement. Okay, the questions are coming like this, it means we have to solve the problems. Okay, question number 8 now. Question number 8. So again, I have told you this, there's a hint given to you from my side. Whenever you have sum of the inverses, convert in terms of tan inverse, life will be easier. Convert in terms of tan, we have a tan inverse of 1 by 3 plus tan inverse of 1 by 4 plus tan inverse of 1 by 5 plus tan inverse of 1 by n equals to pi by 4. Equals to pi by 4. Let's solve it one at a time. So we have to solve, sorry, 2 at a time. Let's take these two together. So we get tan inverse 1 by 3 plus 1 by 4 will become 12. 3 plus 4 divided by 1 plus 1 by 12, right? 1 plus 1 by 12, no, not plus, 1 minus, right? 1 minus 1 by 12. Okay. This is correct. Right here, tan inverse of 1 by 5 plus tan inverse of 1 by n equals to pi by 4. Equals to pi by 4. Okay, I'm getting here 7 by 11, I think. Yeah. Tan inverse of, this is 7, this 12 and this 12 be cancelled, okay? So I get 7 by 11. 12 into 1 is 12, minus 1 becomes 11. Do the calculation, okay? And over here I get tan inverse of 1 by 5 plus tan inverse of 1 by n plus pi by 4. Again I will combine these two. I get now tan inverse of sum of these two LCM will be 55. Okay, so 7 11 5 means 35 I get over here, plus 11 5 is 55, 7 5 is 35, 5 11s is 55, then 11 1s is 11. This is numerator part. Check the denominator out. You have to take the difference. 1 minus difference of the product. I get 7 by 55. I get 7 by 55 plus tan inverse of 1 by n plus pi by 4. Just few more steps and we get the question done. Okay, simplify this. I'm going to do what? I'm going to keep this term over here, okay, and rest all on take the other side. Tan inverse of 1 by n over here. I have written here pi by 4, right? I can write this as tan inverse of 1, if you remember. Tan 1 is pi by, sorry, tan pi by 4 is 1. So tan inverse of 1 is pi by 4. Moving this part on that side, I get minus sign first of all. This positive tan, this whole thing I'm moving on the other side of the equal to, becomes negative. Comes what, dear? Tan inverse first. Comes what? Tan inverse first. Okay. Now check this out. 35 plus 11, how much is that? 46. Right? And this will become 55 minus 7. How much is that? 48. Right? What about 55, sir? They get cancelled. Okay? 55 minus 7 is 48. Okay. So we get 23 and 24. 24 and 23. Okay? Again, another formula, tan inverse of A minus B. I get 1 minus 23 by 24. I forgot to write tan inverse. Check this out. Tan inverse of 1 minus, right? 23 by 24 upon 1 plus 23 by 24. Simplify this. I get tan inverse 24 minus 23 is nothing but 1 by 24 and divided by 24 plus 23 is 47 by 24. Cancel, cancel. I have the answer as tan inverse of 1 by 47. What is this side? Continues over here to tan inverse of 1 by n. Compare these two. Value of n is how much? Value of n is 47. Value of n is 47. Answer is 47. Fair enough? Clear? Okay. Any problem? No. See, another simple question. Another simple question. Yes. So whenever the question is like this, we feel happy, but yes, there can be a question which might be challenging to us time to time. For example, this one, easiest question of all, just understand the question statement. Okay, this was clear, right? This was clear, no? 8th one was clear. Have a look one more time. 9th one is the easiest question of all time. Have a look. What are they saying? Let the inverse trigonometric functions take principal values. Okay, the number of real solutions of the equation 2 sin inverse of x plus 3 cos inverse of x. Take it together, we get 2 times of pi by 2 plus cos inverse of x equals to 2 pi by 5. Think about it. Think about it. Think about it. what I'm saying here, if I take separate this 3 cos inverse of x as 2 cos inverse of x plus cos inverse of x, and combine these 2 cos inverse of x and 2 sin inverse of x as 2 times of, I'm talking about this 2 sin inverse of x plus cos inverse of x, what it becomes? 2 times of pi by 2 na? How much is that? Pi plus cos inverse of x equals to 2 pi by 5. Yes. What are they saying? Principal values, very important word. We don't feel this is important, but very important. Principal values of cos inverse of x. What is the principal value of cos inverse of x? Principal value of cos inverse of x is, sir, between 0 to pi. I'll repeat myself. Principal value of cos inverse of x is between 0 to pi. Can you use any of the value over here to add it to pi to get 2 pi by 5? Think. 2 pi by 5 is already smaller than pi. 2 pi by 5 is already smaller than pi. Can you use any positive number to be added to pi to get 2 pi by 5? Never. Therefore, no solution, sir. Answer is, sir, 0. Answer is 0. The number of solution is what, sir? 0. Okay. I write here answer is 0. Please check. Had fun? Simple enough. Okay. Simplest question of all the paper. 9th is done. Question number 10 now. In the 9th one, you have to remember what things. Remember that it is talking about the number of solutions and also principal value. Yes, we can have a value over here. If this was just a variable, I can find it. No, bring 2 pi 5 over here and get the answer. Okay, I can bring 2 pi by 5 over here and get over there. I'll get a negative value, that will be okay. But they are saying that principal values. There is no principal value which will make this equation satisfied. Okay, hence I have answer as 0 solutions. Question number 10 now. On the binary operations, they have already given you instructions on the binary operations. Kindly use this statement to get the result of this. Sir, very challenging. Very challenging. Is it? We'll check. We'll check, sir. Challenging or not. So, operation which is given to us. X asterisk y. X asterisk y is nothing but first term's square, second term's cube. Apply to the conditions that is given to you. First you take this. We'll find x asterisk 1. What I get for this? Square of first term and cube of the second term. How much is that? X square plus 1. What is the next thing they're saying? X asterisk 1, that asterisk with 1. It means now this is the first term. So x square plus 1 asterisk 1. What it means? X square plus 1 the whole square plus the 1 value over here, the cube. Got it? X square plus 1 the whole square plus 1. Okay, this is my value. X square plus 1 the whole square plus 1. This is your condition of this. X asterisk 1 asterisk 1. Okay, let's move on to the next step. What is that? X asterisk 1 asterisk 1. So we'll find first 1 asterisk 1. What I get for this? 1 square plus 1 cube. How much is that? 2. Now next step is going to be x asterisk 2. Correct now? Because this is going to be 2 only, right? So basically one step I can do. 1 second. X asterisk I can write 1 asterisk 1. Okay. X asterisk 1 asterisk 1 equals to x asterisk 2. How much is that? So x square plus 2 cube. How much is that? Simply x square plus 8. Now they are saying that this is going to be equal to each other. These two. Put them equal to each other. Put them equal to each other. What I have? X square plus 8 equals to x square plus 1 the whole square plus 1. Expand, I get x square plus 8, x square, the square means x power 4. Simple calculations, pay attention please on the board. X power 4 plus, we get 2x square, okay, and we get 1 plus 1. 1 plus 1. That's right. we get here 1 as 1 and we get 2x square. Simplify this, we get here 0 x power 4, we get plus x square and we get minus 6, okay. So if I have to solve this equation, I'll have here x square minus 3 plus 2, I think, plus 3 minus 2 will work, plus 3 and minus 2 will work. Check. This is the factorization of the given quadratic form. If I take x square as the variable y, this will become y square plus y minus 6, right? Okay. So it becomes what? If you expand it, you're going to get x square, x power 4, and we get 3x square minus 2x square becomes plus x square, and answer is minus 3 into 2 will become minus 6. Okay. So from here I get x square value is either 2 or x square value is minus 3. Not possible. X square value is only 2. Use this in this condition. What I have this condition, this is going to be 2 sine inverse of x square means x power 4 means x square the square. So 2 square. How much it is? 4 plus 2x square is 2 minus 2 divided by again 4, x square is again 2 plus 2 in this time. So we get 2 and 2 is cancelled. I have here 2 sine inverse of 4 by 8. I get 2 sine inverse of 1 by 2. How much is it? 2 into pi by 6, I think. Sine inverse of 1 by 2 is pi by 6. Final answer is pi by 3. Final answer is pi by 3. Pi by 3, option B is correct. Please check. Option B is correct, sir. Got it? Pi by 3 is the final answer. I hope this is clear. They have given the binary operation. We have followed it to the statement they have given. We got the results for both the terms, this part and this part individually. First is done over here. Part 1 is done over here. And part 2 is done over here. Use part 1 and part 2 together, okay, to get the result for the quadratic form, and then solve that by factorizing. Okay, if you want, you can do the steps from your side to get the factors, and from there we get a negative value for square. Not possible. So x square equals to 2 is okay. Use that in the given form they're asking, sine inverse form, and answer is coming as pi by 3. Fair enough. Question number 10 is done. Very good question. 11th one now. Sine inverse of x by alpha, cos inverse of x by beta. Again, a very simple question. You will find it very, very simple, don't worry. So we'll do one thing. It's a given form, right? Take it equal to some constant. Some constant we can take right over here. Let's take the constant k over here. Okay? Because the ratio is equal, I can take this as a constant k. Okay? So if I do that, I get sine inverse of x as k alpha and also cos inverse of x as k beta. Okay, let's add these two. So I get sine inverse of x plus cos inverse of x equals to k alpha plus k beta. Take k common, I get alpha plus beta. This part, no problem. Take in k common, alpha plus beta. Sine inverse of x plus cos inverse of x. What is the answer? Pi by 2. Right here, pi by 2. Check. What are they asking us? Sine 2 pi by a, 2 pi alpha by alpha plus beta. Sine 2 pi alpha by alpha plus beta they are asking us. Okay? It means I need the alpha plus beta value, something. So I'll get the alpha plus beta free from there. Okay? So from here you can see directly, I'm getting pi by 2k equals to alpha plus beta. Okay? So far so good. Now I want alpha plus beta in the denominator. Please check. In the denominator. So I'll take the reciprocal on both sides. So I'll end up with alpha plus beta in the denominator 1 by this equals to, it'll become 2k by pi. 2k by pi. Works. I want 2 pi alpha also in the numerator. I'll multiply on both sides. So 2 pi alpha by alpha plus beta. Here 2 pi alpha into 2k by pi. Pi and pi is cancelled. I get over here 4 k alpha equals to 2 pi alpha plus beta. Now there is a sign on both sides. Apply sign on both sides. Sine of 2 pi alpha upon, I am doing all the steps so that it is self-understood also. Okay, I'm not skipping anything so that you can make sense from your side also. Sine 4 k alpha. Check this out. I have something for k alpha. What is that? It is sine inverse of x. Last few steps. So we have sine of 4 k alpha equals to basically 4 sine inverse of x. Check this out. I want to find this value, but that is equal to sine 4 k alpha, and k alpha is equals to sine inverse of x. I can write k alpha as sine inverse of x. Now if I take this value as something called theta, let's say, if I take this value as something called theta, it means my x value will become sine theta. Okay, and we have the formula sine of 4 theta can be written as 4 sine theta cos theta 1 minus 2 sine square theta. That's the formula. For sine 4 theta, 4 sine theta cos theta 1 minus 2 sine square theta, one of the form which is over here. Check this out. I get this as 4 sine theta is nothing but x. Cos theta will become a root of 1 minus x square. Okay, and this whatever is going to continue from here, doesn't matter. Answer will become option B. Only one option like this, please check. 4x with only one option is like this. Compare, you're going to get the same answer, 1 minus 2x square. Option is B. Answer is option B. Okay, yeah, so this is little tricky to understand. There are a couple of where you have to remember those steps. For example, over here, taking the constant part, from there you have to identify that what we're looking for. So we're looking for alpha plus beta. We're looking for alpha plus beta, the angle. So first we got that part, then what we're going to multiply to alpha plus beta to get that angle. So we have to first reciprocate it. We've taken the reciprocal first, then comes multiplication of 2 pi alpha. Okay, and then simplify this to get 4k alpha, apply sine on both sides, and then replace k alpha by sine inverse of x, taking that as theta, apply the formula of sine 4 theta, 4 sine theta cos theta, and 1 minus 2 sine square theta. Okay, you get the result also as option B. Fair enough, easy. Question number 11 is done. Some tricks bit, but we can solve it, right? 12th one now. Question number 12 now. Okay, sine inverse of sine 2 pi by 3. This is a very simple question, isn't it? Okay, angle 2 pi by 3, which quadrant? Second quadrant. 120 degrees, second quadrant. What happens to sine? Positive. So we can become sine inverse of simply root 3 by 2, na? Sine 120 is how much? Sine 120 is cos 30. Cos 30 is how much? Cos 30 is how much? Root 3 by 2. Okay. Over here, this will become which quadrant? 7 pi by 6. So third quadrant, right? Third quadrant. So negative. Cos inverse of root 3 by 2 with a negative sign. Okay. Negative sign. It will become cos pi plus pi by 6. So it will become cos pi by 6 only. Pi by 6 is cos 30, which is root 3 by 2. But third quadrant is so negative. Not sure, apply the special angles, that table. Okay, I've taught you in the bridge course. Go check the table, special angles of trigonometric ratios. You get the conditions from there. Third quadrant is 7 pi by 6. Cos pi plus pi by 6 is 7 pi by 6. Remember how to solve it? Third quadrant, cos pi by 6 will be negative as minus root 3 by 2. This will become what? Again second quadrant, right? So tan inverse of minus 1, I think. Yeah, minus 1. Correct. Let's solve it. So we get over here as pi by 3. Over here we get pi minus pi by 6. Correct, right? Cos inverse of root 3 by 2 becomes pi minus cos inverse of root 3 by 2. So becomes pi by 6, and for this we have minus pi by 4. Okay, LCM is 12. 3 4s are, so 4 pi. We have 12 pi. 1 second, I can simplify this better. So 1 second. So we have pi by 3 plus 5 pi by 6 minus pi by 4 actually. Okay, now you take LCM. So 12, 3 4s are 4 pi plus 10 pi minus 3 pi. Okay, 14 minus 3 is 11, right? 11 pi by 12. Option is A. Option is A. Have a look. Option A is correct. 12th option A is correct. Okay. So this is a simple question. Very simple one. Moving on to question number 13 now. Chali. 13th question. Again, sum of inverse trigonometric functions. What we do? Convert everything in terms of tan inverse and do the job. Okay. So should I give this as homework? I'll do few steps and then I'll tell you the answer also, but you have to do some steps from there. Okay. I'll give you the steps, few steps I'll show you. I'll explain you the question. I'll give you the final answer also. You have to try from your side the rest of the part. So first of all, two things are already in terms of 2 tan inverse. That is a simple part for us. Only thing is sec. Use that. So we have here sec means what? Sec means that this is going to be 2, this is going to be root 5. Okay. A square of this is 5 minus 4, which is going to be 1. This is the angle, let's say theta. So I get that angle as tan inverse of 1 by 2. Okay. So before that, I'll combine these two together. 1 second. I'll combine these two together. So I have here tan and take 2 common. Okay. We have tan inverse of 1 by 5 and 1 by 8. Take the sum. So LCM will become what? 8 5 is a 40. 5 plus 8. Okay. And difference 1 minus 1 by 40. Okay. And we have plus tan inverse of 1 by 2. From where, sir? From here. From here. If I take this angle as theta, no? This is the theta value. Okay. So simplify this. I get tan 2 tan inverse. Okay. And this is going to be 13 by 40 and 39 by 40 plus tan inverse of 1 by 2. Please check. 40 cancelled. 13 3 is 39. Okay. So I get tan inverse of 1 by 3 to tan inverse of 1 by 3 plus tan inverse of 1 by 2. Tan inverse of 1 by 2. Now we have to apply one more formula over here. 2 tan inverse formula. Okay. For that we have, check this out. Tan inverse of 2 into 1 by 3 and we have 1 minus 1 by 3 square. Okay. 1 by 3 square. 1 by 3 square. 2 tan A upon 1 minus tan square A. That's the formula. And this remains as it is. Tan inverse of 1 by 2. Tan inverse of 1 by 2. I think from here you can get the answer. I'll do one more step. Yeah. Fine, I've done everything anyway. Tan inverse of, I think 2 by 3 divided by 8 by 9, I think. Please check. Tan inverse of 1 by 2. Have a look. So I get 1 by 9 over here. LCM will become 9. 9 minus 1 will come in the numerator. It becomes 8 by 9 and this is 2 by 3. Cancel. So we get 3 3s are 9 and we get 2 4s are 8. So last step you have to do from your side. Okay. Tan inverse of 3 will go up. 3 by 4 plus tan inverse of 1 by 2. So what is your, I've done everything, just do one more step. One more step is required. Step is required. So your job will be to give me answer. This is your homework, okay? Homework will be, give me final answer for question number 13. What is the right answer? Give me that, okay? That's my homework to you, all of you. So I want to know how much of you are solving the question. So answer for 13th one, I want from all of you, okay? Just you have to solve one more time tan inverse, A plus B. Do that and you're gonna get the result. Let me know what is the answer coming as, okay? So for the question number 13, I want the answer from all of you. Done. Question number 14 I'll solve now. Question number 14 I will solve now. Works? Okay. So cos sine inverse, look, whenever you see series of functions like this, they are given to make it cancel to each other. or make some modifications using the triangle, the Pythagoras theorem, that triangle, okay, right angle triangle. So instead of starting from the first, start from the what is in the last, okay. So check this out. If this is my angle theta, this becomes cos theta, right? If I take this as theta, it becomes cos theta, okay. So what is this whole thing becomes? Simply, please check this out, it becomes 1 minus x square in the root. 1 minus x square in the root, okay. Now on that, what will operate? You'll have the operation of tan inverse on it. Yeah, but we have cot outside, okay. It means I should convert this tan inverse into cot inverse. How do you do that? Write this as cot inverse of 1 upon 1 minus x square. Now on this you have what operating? X cot. One second. On this you have operating x cot. So write that x cot. So cot inverse cot will be cancelled. You have only x upon root of 1 minus x square left. Outside of this you have sine inverse. Okay, outside of this you have sine inverse, and out of that you have cos. Achha, I hope you got this part right. If theta is sine inverse, I hope you know that. If theta is sine inverse of x, it means x is sine theta, right? So what do you get for cos theta? Root of 1 minus x square. Okay, this part. This represents your cos theta, okay? So what are they saying, no? For this given expressions, there are two roots, okay? Alpha and beta, and those two, and they are also given an equation x square minus bx minus 5. For this there are two roots again. First root is 1 by alpha square, and second is first root is 1 by alpha square plus 1 by beta square, and second root is alpha by beta. Second root is, the first root is the entire part, the 1 by alpha square plus 1 by beta square, and the second root is alpha by beta. They are asking you to find the value of beta by k square. It's a NAT, okay, numerical answer type question. So a little bit challenging, of course, but we'll solve it. Sine inverse of x upon root of 1 minus x square is we are getting over here. Now if I take this as some angle, let's say alpha, some angle alpha, then I'm looking for what? I'm looking for cos alpha. Check this out. I'm looking for cos alpha. So it simply becomes in the root, okay. So if you take this out, this is sine alpha, right? So this is x over here, and this is root of 1 minus x square. So this part will become, dear, 1 minus x square minus x square. Correct now? Right? Square of the hypotenuse will become simply 1 minus x square minus the square of this term will become x square, and whole thing inside the root. So basically this is coming as root of 1 minus 2x square. This part only. So cos alpha will become 1 minus 2x square upon the hypotenuse, which is nothing but root of 1 minus x square, and this is given as, please check, k, given as k. So put that k over here. 1 minus 2x square, 1 minus x square inside the root. Okay, this part is clear. So if I want to find the value of squares, so let's find the value of k square actually from here. Want to find the value of k square from here. I'll end up with 1 minus 2x square numerator and 1 minus x square from here. It's not done yet, just giving you the value of k square from here. 1 minus 2x square upon 1 minus x square. I have to find the value of x square actually. Check this out. Okay, value of x square actually, because that's going to be the roots or the solution of the given equation. So if I have to check, I was getting k square equals to 1 minus 2x square upon 1 minus x square, cross multiply. I get k square minus k square, x square equals to 1 minus 2x square. What I can do is I can take this term over here. I get 2x square minus k square x square equals to 1 minus k square. I'm moving this k square on this side and this on this side, okay. Take x square common over here. I get 2 minus k square equals to 1 minus k square. So I have x square equals to 1 minus k square, right, upon 2 minus k square. Now we are very close to the answer now. we're getting the value of x now. Okay, if you take the root of this, how many answers you're gonna get? 2 answers. And what they said one value is alpha, other value is beta. It means I'm gonna get the value of alpha and beta now. Okay, so take the root now. I get x value as plus minus this whole thing root 1 minus k square upon 2 minus k square, where the plus value represents alpha and beta represents the negative value. This is done. But this is the question what they're asking? Not at all, sir. What are they asking actually is to find the roots which are of the order 1 by alpha square and 1 by beta square. So I'm going to take each of them, reciprocate, and then square it up. And then again add. Okay. Then again add also. Check this out. So you have this value 1 by alpha square plus 1 by beta square equals to inverse of that, and then you add it. What are you going to get? Twice of, but it will be reciprocated. So 2 minus k square upon 1 minus k square. How come? I'll repeat myself. You reciprocate because alpha is going to be what? Your alpha value is 1 minus k square upon 2 minus k square. And your beta value is what? Beta is simply negative of alpha. Beta is simply negative of alpha. Okay? Beta is simply negative of alpha. So if you take alpha square or beta square, both will become free of root and positive, and you have to reciprocate because of they are saying 1 by alpha 1 by beta square. That's why the 2 minus k square comes in the numerator and 1 minus k square goes in the denominator. Okay, now this is one thing which is clear. They are saying that what is the second root? The second root is this is not the root. This is the first root actually. This is the first root of the given quadratic. Which quadratic, dear? This quadratic. X square minus bx minus 5 is a quadratic equation. For that, this is the first root. Please check. Solutions means root. For the given equation is one of this is over here. Second root is over here. Second root is what, dear? Alpha by beta. Check from here. They are both equal. You can get this as minus 1. This is my second root. Both the roots are equal but negative in sign. Okay? It means if you take the ratio of them, you'll have the answer as minus 1. Second root is going to be minus 1. Okay? Great. Now we're going to take the value of the properties of quadratic. Sum of roots. Have a look. Sum of roots. Or before that we can do product of root, I think. Yeah, let's do product of root before that. It'll be easy for us. We'll do product of roots. Product of roots. When I do that product of roots, have a look. Multiply these two. Okay, so we'll have simply minus 2 times of the same bracket, 2 by k square and 1 minus k square. 2 minus k square, 1 minus k square with multiplied with minus sign. Okay, this thing multiplied with the minus 1 because this is the second root over here, first root over here. Okay, this is clear. Product of root, check this quadratic over here. Check the quadratic over here. Product of the root is how much? Simply minus 5. Product is how much? Simply minus 5. Minus and minus is cancelled. I can solve the value of k square from here. I get 4 minus 2k square and I get 5 minus 5k square. Simplify this. Okay. So I'll bring it on this side. I get 3k square equals to 5 minus 4. It means k square equals to 1 by 3. K square is 1 by 3. 1 second. Okay, I need to have some more space just to solve this question. Yeah. So right here, product of roots. Product of roots. Now what are they asking actually in the question? They're asking us to find b by k square. You see this. So before I go on to do that, we need to find what? Sum of the roots. Let's find sum of roots. What do we get for that? Sum of roots. Check this out. First root is this condition, second root is this condition. So we have to add minus 1 to 2 times of 2 minus k square upon 1 minus k square. This is my sum of roots. Yes or no? Adding both the roots. And this is equal to what? Negative of the coefficient of x. So we get minus of minus b. We get property of this, right? Minus of minus b. How much is that? Simply plus b. What are we looking for? We're looking for b by k square. Do I know the value of k square? Yes, k square is coming as 1 by 3. Simply divide this by k square. check this out. I'm dividing this term by k square over here. Okay, I'll divide it over here also, minus 1 upon k square. Here also have to divide, plus 2 by k square. This whole bracket continues. Okay, check this out. I'll write it over here, b by k square, and simplification. I get minus 1 upon 1 by 3. First term. Second term, what I have? Plus, right here 2, and inside this right here 2 by k square minus right here 1 over here, right? 1. And we get here 1 minus k square. 1 minus k square. Simplify this. I have minus 3 plus 2 times of 2 by k square means 6 minus 1. 1 second. Okay. Have I done some mistake? Have I done some mistake? If I do that, I get, yeah, doesn't matter. 6 minus 1 upon 1 minus 1 by 3, right? So I get 2 by 3 over here. Okay, so minus 3 I have, plus 2 times of 5 upon 2 by 3. Okay, so 2 and 2 is cancelled, 3 goes up. Okay, so this is I'm getting as minus 3 plus 5 into 3 is 15. How much is that? 12. That's my final answer. This is my final answer, dear. Okay, this 12 is my final answer. Please check. This 12 is my final answer. It's a tough one. Okay, it's a tough nut to crack, difficult one. So please, I'll show you the questions flow one more time before we move on to question number. Next is 15, right? So we have few more questions to solve. Just this question, pay attention one more time. What I've done over here is, so they gave this sequence of functions together, inverse functions. So I started from the cos sine inverse, taking this as theta, got cos as 1 minus x square, then solved for tan inverse, wrote tan inverse in terms of cot inverse. Cot inverse, for that I had to just take the reciprocal of the inside. Okay, from there I operated cot and cot inverse, cancelled. I get x by root of 1 by x square, 1 minus x square in the root. And then sine inverse is there. I've taken that as alpha. I want to find cos alpha, so I've taken this as Pythagoras theorem. Okay, from there, this is basically my alpha. I get cos alpha as, what is it? 1 minus 2x square upon 1 minus x square. This is nothing but equal to k from here. Squaring on both sides gives me the k square value. Solving that, I get x square in terms of k square. Okay, now they're saying that alpha and beta are the solutions of this given form. Alpha and beta are the solutions of this given form of ITF. So from there I get two values of x, which is nothing but, one is 1 minus k square by 2 minus k square, and second one is going to be what? Okay, this is in root, sorry. This is going to be in root, okay? Yeah. So 1 minus k square upon 2 minus k square, other one is negative 1, which is beta is negative of alpha. Now they have said that in the question itself that for the another quadratic which is given to us, x square minus bx minus 5, there were two roots. One root was square, so 1 by alpha square plus 1 by beta square. This was one of the roots. Another root is alpha by beta. So I found this 1 by alpha square, 1 by beta square. If you do that, you're going to get rid of the squares, square roots, and then simply add that. 2 times of 2 minus k square, 1 minus k square I get. Okay, and alpha by beta will become minus 1 because they are both equal but negative in sign. Yeah. And then I use the product roots to get the value of k square from here. Then I use sum of the roots. I got something in terms of b. From there I divide the b by k square, which is given as 1 by 3. Solve it to get the answer as 12. This is your final answer. Please check. This is your final answer. I hope this is clear. Do not worry. You'll get the class notes to you in the PDF format. Where are you going to get that? In the WhatsApp channel. So the channel link will be given in the description of this video. Go ahead, check that out. Join the WhatsApp channel and get the class notes and revise the question and again. Okay, again and again, because very simple, difficult problem, might be challenging, little lengthy also. So first read the question, pause it, watch it couple of times, and then solve the question again. Important. Asked in 2022, shift 1, 27 July. Please check. 14th one is done. Okay. All right. So 15th question. Let x equals to sine of 2 tan inverse of alpha, sine of 1 by 2 tan inverse of 4 by 3. Solve for this. Okay. So I hope this is clear, right? 14th one is clear. Okay. Have a look one more time. Let's solve 15th one now. Now the last 4 questions. Question number 15, let's solve it. X, okay, sine of 2 tan inverse of alpha, sine of 1 by 2 tan inverse of 4 by 3. Okay, we have formula for this, right? We have formula for this. X equals to sine. Okay, I can write this in terms of directly tan. Okay, actually make our life simple only in order to challenge ourselves. So becomes 2 tan of, okay, so 2 actually 2 alpha will become 2 tan of tan inverse of alpha, it will become simply 2 tan alpha, 2 alpha, excuse me. So what I do know, if you write sine in terms of tan, it becomes 2 tan alpha actually. So this angle itself will be there. Tan of tan inverse will become cancel each other. You have to operate tan of tan inverse. Operate tan of tan inverse will be cancelling each other. So 2 alpha you'll have. In the denominator you'll have 1 plus tan square of. So tan square of tan inverse. So you'll get simply alpha square. Do one thing, apply the formula of this one. Sine 2x in terms of tan. Do that formula. Okay. Write the formula of sine 2x in terms of tan. So x equals to 2 alpha by 1 plus alpha square is this condition from x. So we want also we want to use alpha from S, the summation over here for this condition. But alpha, for that I need y square also. I need y square also. I have the x square, no problem, but y square. Okay, simple enough. Y equals to sine 1 by 2 theta. Taking tan inverse of 4 by 3 as theta. Tan inverse of 4 by 3 as theta. Okay. So triangle, this is theta, this is 4, this is 3, this is 5. Alright. Now sine, this is a formula actually, sine square theta by 2 actually, not theta by 2, theta actually, theta is given by 1 plus 1 minus cos 2 theta divided by 2, right? This is the formula. Everyone will agree, right? 1 minus cos 2 theta by 2 is given by sine square theta. Okay, formula of cos 2 theta in terms of sine square. All right, so let's find it out. If I do that, okay, no, actually it's going to be theta only, right? It is theta by 2, no? It's going to be theta by 2 over here. This is going to be theta only. I missed it. I was right in the first part. Yeah, this is theta by 2 angle, not theta. You can see that this angle is theta by 2, half of theta, right? So theta by 2. Sine square theta by 2 will become 1 minus cos theta by 2. Okay. So we have cos theta from here. Cos theta will become 3 by 5. 3 by 5. Check 1 minus 3 by 5 by 2 gives me 2 by 5 by 2 gives me 2 by 5 by 2. 2 and 2 is cancelled. So I get here sine square theta by 2 equals to 1 by 5. So sine theta by 2 equals to root of 1 by 5, right? And which is same as y. It means my y value is equals to root of 1 by 5. So far I think this is all clear, right? Check this out. So y value was sine of theta by 2. I took this as theta, right? Tan inverse of 4 by 3. So y value sine theta by 2. From there I got sine theta by 2 as 1 by 5 in the root. Okay, I can replace y value as root of 1 by 5. Now I'm going to put this and this together. Check this out. So I get here y square means y square equals to 1 minus x is there, right? So 1 by 5 equals to 1 minus what is x? 2 alpha upon 1 plus alpha square. I hope all of you got how I got 1 by alpha square, right? 1 upon 2 alpha upon 1 plus alpha square by taking this formula. Sine 2x in terms of tan x, okay? Remember the formula. So from here I get what? 1 by 5 I have. Take the LCM, I get 1 plus alpha square minus 2 alpha upon 1 plus alpha square, I think. 1 second. Yeah. Cross multiply, I get here 1 plus alpha square equals to 5 alpha square minus 10 alpha. On this side I get 0, 4 alpha square, okay, minus 10 alpha, okay, and we have what is it, plus 4, I think, correct. 5 alpha square minus alpha square is 4 alpha square minus 10 alpha, and we have 5 minus 1 is, which is 4. This becomes 2 alpha square minus 5 alpha plus 2 equal to 0. Okay, so I have to make the factor over here. I get the factors as 2 alpha minus 1 and alpha minus 2. Please check. I'll show you once again. If you want to factorize it from your side, basically the factor will become minus 4 alpha and minus alpha. The factor of this will be what? Minus 4 alpha and minus alpha. Check this out. 2 alpha into alpha, 2 alpha square, 2 alpha into minus 2, minus 4 alpha, minus alpha into, so minus 1 into alpha is minus alpha, becomes minus 5 alpha, and minus 1 into minus 2 becomes plus 2. Okay, so from here I get the value of alpha as 1 by 2 or 2. Now check the summation part. What the summation is asking us? Summation of all the alpha from this set S under 16 alpha cube. Summation of 16 alpha cube for all the alpha. 16 into 1 by 2 the cube plus 16 into 2 cube. Any more alpha is there? No. We get only two values of alpha, 1 by 2 and 2. Solve it. So I get 16 into 1 by 8 plus 16 into 8. This is 2. This is 128. Yeah, correct. 130 is the answer. Please check. So this will be coming as 130. That's the final answer. Got it? Please check. Simple question. 15th one is done. Yes. Clear. Visible. Question number 16 now. Question number 16. Value of tan inverse of cos 15 pi by 4 minus 1 upon sin pi by 4. How do you solve this question? How do you solve this question? Looks simple enough to me. Tan inverse is there. Cos 15 pi by 4 becomes 4 pi minus pi by 4. So yeah, cos of 4 pi minus pi by 4 minus 1 upon sin pi by 4. This is good. Okay. So this will become what? Tan inverse of fourth quadrant, right? So 1 by root 2, I think simply. Cos pi of 4 become 1 by root 2. Fourth quadrant means it will become cos pi of 4, which is 1 by root 2. Okay. Take LCM now. So I have LCM as 1 minus root 2 upon. Simply root 2 and root 2 will cancel. That's it. Tan inverse of 1 minus root 2 is the answer. Okay. So if I take this value in this form, tan inverse of root 2 minus 1, I'll get a minus sign and write this equals to minus alpha. Okay. So basically I'm asking you to do what? I'm asking you to assume this value of tan inverse of, I'm asking you to assume this tan alpha equals to root 2 minus 1. What I've done over here, I've taken minus sign common. Okay. I've taken minus sign common. Okay, it becomes minus root 2 minus 1, and minus 1 will come out in tan inverse. We know that tan inverse of minus x is how much? Tan inverse of minus x is how much? Minus tan inverse of x. This property. Tan inverse of minus x is nothing but minus tan inverse of x. Got it? So I have done that, and then I have assumed this to be minus alpha, so that I get tan alpha equals to root 2 minus 1. Why? See that over here. I can write this as tan of 2 alpha actually. You see. So because now tan alpha is giving me no values actually. So I have one formula that I know which I can try over here. How will you know this? By practice only of so many questions. So tan 2 alpha will become what? 2 tan alpha 1 minus tan square alpha. So we have 2 times of root 2 minus 1 upon 1 minus square of tan alpha means we get 2, we get plus 1, and we get minus 2 root 2. Check this out, 1 and 1 is cancelled. So I have here 2 times of root 2 minus 1 divided by, I get this is positive means 2 root 2 is positive, minus 2. Cancel. Okay, I can take this 2 common. In the denominator also 2 is common. I get root 2 minus 1. 2 is common means root 2 minus 1. These 2 are cancelled. This 2 also is cancelled. Alright, so I get the value of tan 2 alpha. Now, take this out. So my 2 alpha is coming as pi by 4. Because tan pi by 4 is 1. This value is coming as what? Have a look. This value over here is nothing but 1. Right? 1. So tan pi by 4 is 1 means tan 2 alpha angle is pi by 4. It means alpha value is what? Is pi by 8. Alpha value is pi by 8. What is the question we had? We had this term which was coming as negative. Okay. So if you want to find this value, I have to get what? I have to get what? Minus pi by 8, right? I have to get, this is pi by 8 is alpha. I want minus pi by 8, no? This is nothing but minus alpha. So minus pi by 8. Yes or no? This is same as this. This will be minus alpha. It means this whole thing is minus alpha. Alpha is pi by 8 means answer is minus pi by 8. Option B is correct. Have a look. 16th is done. Okay. 2 more questions to go. I hope this is fun. You got it right. Clear. 17th we'll solve now. Question number 17. This is just for the property. Okay. 17th one. Alright, let's solve the question number 17. What we have, the inverse trigonometric functions take principal values. Okay. Okay. We can do that. Not a problem. Cos inverse of 3 by 10. Cos of tan inverse. We have to use the triangles actually. Triangle, if I take this as same values there, no? Let's call it to be theta only. Both as theta. This is theta. Tan means 4 is here, 3 is here, this is 5. Pythagorean triplet. We want, this is nothing but written as cos inverse of 3 by 10. Okay. And this is cos theta plus 2 by 5 sin theta, right? If I take both values theta only, I get cos theta and sin theta. We know the value of cos theta. Have a look. 3 by 10. Cos theta is how much? 3 by 5. Plus 2 by 5 as it is. Sin theta is how much? 4 by 5. Right? 4 by 5. Sin theta is 4 by 5. LCM cos inverse 50 here, 25 here. LCM will be 50 only. This is 10 into 5, so 50. 5 into 5 is 25. LCM is what? 50. I get this as 3 into 3, which is 9. 4 into 2 is 8. But LCM is 50 here, this is 25. Multiply that by 2. So 8 into 2 is 16. Right? 50. This is 25, this is 50. 25 into 2. So 4 into 2 is 8 into 2. So 16. What I get for this? Cos inverse of 25 by 50. Correct now? 9 plus 16 is 25. Cancel 2. Cos inverse of 1 by 2. They are talking about principal value branch. Okay? Principal value. Answer will be pi by 6. Pi by 6. Option D is correct. Because cos 30 is, no, pi by 3, right? Excuse me. 1 by 2 they ask me, right? Cos 60. So this is going to be pi by 3 actually. My mistake. Pi by 3. My mistake. They're asking. Yeah. Silly mistake. 1 second. Option C. Right? Cos 60 is 1 by 2. Pi by 3 is 60. So cos 60 is 1 by 2. Hence cos inverse of 1 by 2 is pi by 3. That's your final answer. Option C is correct. After that, we have one last question to solve. Let's do it and complete our session. Okay. The cos inverse of cos minus 5. Does it matter? Cos of minus 5? No, sir, because we can write this as simply cos inverse of cos 5. How come? Negative of minus 5 basically in 4th quadrant, right? So, in 4th quadrant, cos is positive. Okay. Sin inverse of sin 6 minus tan inverse of tan 12. That's it. Okay. They are saying that the inverse trigonometric function take the principal values. All right. Now good thing is that all of this is given in the terms of radians. 5, 6, 12 is all in terms of radians. We know that your pi is what? 3.14. So your 2 pi will become how much? 6.28. Your 4 pi will become how much? 5, 6 and 12. Okay. So basically all these values will be so this 5 will be again in fourth quadrant, that also is in fourth quadrant only. Okay, great. So now this will be simple, easy, very simple. I can write this as cos inverse of cos 5 will become 2 pi minus 5. How come, sir? Please check. So I can write this as cos of 2 pi minus 5 equals to cos 5. So why are you doing this? Because they are saying that this is not in terms of their principal value branch. Is it? No. They are saying that write in terms of principal value. So you have to make that change, right? So I am doing that. 2 pi minus 5 I am doing. Okay. Now if I operate cos inverse on this side, cos inverse of cos of 5. Okay. And over here also cos inverse of cos of 2 pi minus 5. This is the question itself. And this side is going to be 2 pi minus 5. Please check. Clear? So this is the question side, cos inverse of cos 5. And this is same, no? Fourth quadrant, cos 2 pi minus 5 is cos 5. Radians of course. So I get cos inverse of cos 2 pi minus 5 becomes simply 2 pi minus 5. That's what I've written over here. Yes. Next step. Now in this case you have to be careful. Because sin inverse of sin 6 is not 6, 2 pi minus 6. I'll show you why. Because what happens is, when you go about this, no, sine of, you write here, 2 pi minus 6. What is the answer going to be? It's going to be minus sine 6. It is minus sine 6. So do I want minus sine 6? No. I want sine 6. For that I have to do what? I have to make the change over here. Minus sine 2 pi minus 6 equals to sine 6. I'll repeat myself. Sine 2 pi minus 6 is nothing but minus sine 6. Fourth quadrant sine is negative actually. All of you agree? Okay. But I want sine 6. I don't want minus sine 6. So I've taken the minus sign over here. So I get what? Minus sine 2 pi minus 6 equal to sine 6. I can take the sign, this minus sign inside also. I get sine of 6 minus 2 pi equals to sine 6. Now you apply sine inverse on both sides. Can you do that? Take this a step. Sine inverse of sine of 6 minus 2 pi equals to sine inverse of sine 6. Okay, this part is same as what is written over here. Sine inverse of sine 6 is written over here, right? And what is happening to on this side? If you operate sine inverse of sine, will cancel each other. Answer will become 6 minus 2 pi. So right here, 6 minus 2 pi. Getting it? Fun? Same way, exact same way it'll work for tan inverse also, because tan inverse in the fourth quadrant is again negative. Is it in fourth quadrant? It is 12, right? 4 pi is nothing but 12.56. Okay, this is all for the working part. Okay, all for the explanation part, not part of the answer. All of this to explain it to you. Okay, only this part is the answer. So this is 12. 12 will be in again fourth quadrant. 4 pi is 12.56. You have to come below that. It means fourth quadrant. Okay, fourth quadrant tan inverse, tan negative. Again you'll have the same approach. You'll have minus tan of 2 pi minus 12 equals, 4 pi minus 12 equal to, what is it? Tan 12. Then you apply tan inverse on that. Do one thing, try it on your side. I'll repeat myself. Minus tan of 4 pi minus 12 equal to tan 12. You have to take the minus sign inside, it will become tan of 12 minus 4 pi. Tan of 12 minus 4 pi here, tan of 12. Okay, what I get now again, it will become simply 12 minus 4 pi. 12 minus 4 pi. Now final simplifications, get the answer after that. So we have 2 pi minus 5 plus 6 minus 2 pi minus 12 plus 4 pi minus 2 pi and 2 pi cancelled. We have here minus 12 minus 5. So first of all 4 pi I have positive, and we have minus 12 minus 5 is minus 17, plus 6 becomes minus 11. Answer is this. Option C is correct. Option C is correct. Please check. Okay, so I hope I have not tried to I have not confused you. If you have, understand this very carefully. We are talking about only fourth quadrant over here because we have the values as 5, 6 and 12. Okay, in that regard it will be negative for sine inverse and also negative for tan inverse, sorry, sine and tan. Sine 6 and tan 12 will be negative, and we're going to solve it like this. Try one thing, do once for the same thing for tan also. 4 pi minus 12 we have to do. 4 pi minus 12. Got it? If you do that, no, 4 pi minus 12, you're going to get this as minus tan 12. 4 pi minus tan of 4 pi minus 12 you're going to do, it will become minus tan 12. From there you can take it on, you'll get the answer as 12 minus 4 pi. What I've written over here. So final answer is option number C, 4 pi minus 11. I hope this is clear. I hope literally that you had fun in the session. I know it was a little challenging. The ITF is like this, sometimes it gets a little difficult, little tricky, okay? But if you are actually, if you solve some amount of questions, things will become easier for you. But right now in the beginning, if you don't know any concept of it, then every question will be new and might be tricky for you. Okay, so I hope I've tried to explain everything to you, and I made an effort to explain everything to you. But if you still have doubt, do one thing. So the problem is I will not be able to explain all the questions of these in the solution videos, so in the comment section. So what you can do is I explained you all the questions in detail. Okay, please watch that question again and again. Watch 3-4 times. If you do that, you'll get that pakka. That's my promise. If you watch the same answer 2-3 times, you'll get that for sure. I've given everything in very detailed fashion. Please promise me that you're going to do that for every question that you're getting stuck on. You're going to get the class notes in the WhatsApp channel. So join the channel right now if you have not joined yet, and get the class notes. And if you're new to the channel, subscribe our channel. We are here to provide quality content for the preparation of your next year's competitive examination. Okay, so join in our journey. Let us be part of your journey. With lot of hard work, we're gonna make good things happen for your career, for our results. Works? So with this I can end the session today. I'll see you again very soon. Till then, take care. Bye-bye.